Welcome to another podcast. In this episode, we're going to be looking at frequency distributions, and we're going to take them a step further by looking at what's called relative frequency and cumulative frequency. Talk about the implications that those have for a data set and some of the interesting features about those. This episode will make a lot better sense if you've watched the previous episode where we looked at visualizing data. In fact, I'm using the frequency table that we produced in that episode for this one as well. This was the GPA data that we had in that last episode. So I'm going to kind of pick it up from here, and we want to extend this frequency table that we already have here by 2 more columns. So let me go ahead and do that right quick. I'm going to extend this out. And I want to make 2 more columns. The first column that I want to make here is what I call called the relative frequency column, or the cumulative frequency column, excuse me. So this is the cumulative frequency, and then the last column is going to be the relative frequency. Both of these are important when analyzing a data set, and I'll talk about what it is that we're looking for in each of them. The cumulative frequency, as the name might suggest, is simply a running total of how many things you've counted in terms of data points. So the cumulative frequency for the first row is always the same as the frequency. Up to this point, we've counted 1 thing. When we move on to the second class, we count an additional 4, so that brings our total up to 5. Here we've counted an additional 5, so 5 plus 7 is 12. Notice what I just did there. To do cumulative frequency, essentially you're taking this number plus 4 and adding it to give this. Each time that's the basic step that I'm going through to get the cumulative frequency. So next up would be 12 plus 20 is 32. And then 32 plus 6 is 38. 38 plus 2 is 40. And one of the key features of cumulative frequency is that this should always be the number of data points, or the size of your sample space if you want to think of it in terms of probability. But the number of data points that you're looking at, for this particular example, when we did this GPA data, there were n equal to 40 data points if you looked at the previous video, and so we should have ended up with 40 there as well, which we did. And that's always a feature of the cumulative frequency. Another thing that this allows you to do is it allows you to sort of separate the data into groups. And so one of the things I might try to say here is what percentage of the data, so let's try to answer this question. What percentage of the data is less than 2? Well, where the cumulative frequency is really nice is you have a total of 5 prior to 2. And so you could simply read that off from there. And so it would be 5 out of 40, which is 1/8, or if you calculate the percentage there, it's 12.5%. This is going to be sort of a handy notion later when we talk about things called percentiles involving what are called normal distributions. And so we'll talk more about this idea coming up later. Finally, on this last column, we have what's called the relative frequency. And the relative frequency, so let me just write a formula for it here. The relative frequency is the number, it's basically the frequency for that row or for that class divided by the number of data points, which we call n. So here the frequency for this first row is 1. We divide it by n, which is 40, and so that has a relative frequency of 1/40th. Here we have a frequency of 4. Don't look at the cumulative frequency column, but look at the frequency. For the second class, we have a frequency of 4, and so the relative frequency is 4 out of 40, or 1 out of 10. So typically we like to list these as percentages, so I'll list this as 2.5%. and this is 10%. All right, next up is we have 7 out of 40. 7 out of 40, I can't really do that one in my head. I could, but let's just talk about, putting in the calculator here. 7 divided by 40 is going to give us a total of 17.5%. Remember to move the decimal 2 places to the right to come up with the percentage. So we have 17.5% for that one. Next up is the fourth class, which is 20 out of 40, or a relative frequency of 50%. And then next up is class number 5, which is 6 out of 40. And that turns out to be a total of 15%. And then finally on this last one we have 2 out of 40, or 5%. Now, one of the features of the relative frequency, similar to the cumulative frequency, is that at the end of this, if you add the total of this column, it should always equal 100%, or if I had it in terms of decimals here, it should equal 1. It just depends on how you want to list things. If I listed it as a decimal or kept it in terms of fractions, it would total to 1. If I listed in terms of percentages, it would total to 100%. Really what this does is it gives us a percentage breakdown for each of the classes, and it's sort of an important way to look at how data is distributed. And we'll talk, once again, like I said, more about cumulative frequency and relative frequency a little bit later in the semester when we do distributions. Thank you for watching this podcast.